Okay, so let's think about this for a second. What if computers could actually work for each other? Do jobs, negotiate payments, build their own little economy, all without us humans getting involved.
Hmm, interesting thought experiment.
Well, today we're doing a deep dive into something along those lines. It's an architectural vision called the sentient protocol. It's pitched as a totally new way to build these autonomous machine-to-machine or M2M economies using nostr.
Right, it's definitely a shift from how we usually think about the internet. A
Yeah.
pretty fundamental one.
Exactly. So our mission today is to unpack this idea. How does it actually reimagine the network? What makes it autonomous? And why should you listening care? Why could this actually be transformative?
Okay, well, to understand why it's different, we kind of need to look at the current internet first. Its core design, people call it the hourglass model, it's built on things like TCP IP, super stable protocols.
Yeah, they just work.
They do, but they're also what some call ossified. Basically, they're incredibly hard to change now. And the whole design principle, the end-to-end principle, it pushes all the intelligence to the edges, to the devices. The network itself stays simple, like a dumb network.
Right. Keep the core simple so innovation can happen fast on the apps and services side. That
Uh-huh.
was the idea. Yeah.
Precisely. Hugely successful idea, obviously,
Yeah.
but that very design makes it really tough to fundamentally change how the network itself operates.
Yeah.
You can't easily make the network itself more intelligent or cooperative in new ways. It kind of fights against that idea.
Okay, so the internet's foundation is sort of locked in place. How does Nostra fit into changing that? Because that's where the sentient protocol comes in, right?
Exactly. This is where things get interesting. The sentient protocol idea sees Nostr not just as a communication layer, which is how most people use it now,
Yeah.
but as an orchestration layer, something that can actually guide how these autonomous machines behave.
Orchestration. Okay. But Nostr uses that smart client, dumb server model. How does that lead to intelligent network behavior? Seems counterintuitive.
Well, it kind of flips the script. It uses those dumb relays as a feature. Think about it. Every interaction between machines becomes a cryptographically signed, verifiable event broadcast across this global message bus.
Uh-huh. Like a public log of machine actions.
Sort of, yeah.
Yeah.
And because you have potentially millions of simple autonomous agents creating and reacting to these events, complex intelligent behaviors can just emerge, but spontaneously. It's emergent intelligence from simple rules and interactions. The simplicity enables the complexity, if that makes sense.
Okay, I think I follow. It's not programming the network top-down, but letting intelligence bubble up. But how do you technically inject this capability? You said the core internet is hard to change.
Right, you're not rebuilding TCP IP. The key innovation they propose is something called a nostr daemon. It's software that runs on the machine and basically augments the standard network stack.
Augments how? What's the magic trick?
The magic is eBPF, Extended Berkeley Packet Filter. It's honestly a revolutionary bit of Linux kernel tech. It lets you run tiny sandbox programs safely inside the kernel itself.
Inside the kernel. Wow.
Yeah, so these eBPF programs can look at network packets, they can modify them, even drop them, all incredibly fast, like native speed. It effectively lets you create a new programmable layer right inside the existing network path, kind of bypassing that ossification problem.
That sounds powerful. Seriously powerful. So you've got this way to make the network smarter at a low level. How do machines use this to actually build an economy? Trust, payments.
Good questions. First step, identity. Just like you have an MPub on Nostr, machines get their own permanent public key identity. Then, this Nostr daemon we talked about, it publishes a special Nostr event like a heartbeat, kindpoint 30166, using NIP66. It signals, I'm online, here's what I can do. Builds verifiable trust based on actual data.
Okay, so verifiable identity. What about money? How do they pay each other?
That uses Nostr's existing payment ideas, specifically NIP57 zaps. Micropayments over the Bitcoin Lightning Network tied directly to Nostr events. A machine requests a task, another machine does it, gets paid instantly with a zap. NIP47, Nostr Wallet Connect, helps manage the keys and payments automatically without a person clicking buttons.
So the machines are literally building value for themselves, like the initial idea. And this payment flow, does it help Nostr itself?
Absolutely.
Yeah.
It creates a direct financial incentive for people running Nostr relays to keep them stable and high quality. If machines rely on your relay for their economy, they'll zap you for good service.
Interesting. So you could build actual marketplaces on this. Like, say, a machine needs an image resized.
Exactly. That's where things like NIP90, the data vending machine standard, come in. One machine posts a job event, need this image resized. Other machines see it, one fulfills it, gets paid. Nostr acts as that universal coordination layer, the control plane, connecting machines needing work done to other machines, or even specialized networks like Filecoin for storage or Golem for compute.
It's a fascinating vision. But, let's address the elephant in the room. Nostr relays can be flaky right now. Scalability is always a question. Security of machine keys.
All valid concerns,
Mm.
definitely. The argument is that the built-in payment model directly incentivizes relay stability pay for quality. For scalability, the eBPF approach is designed for performance, running at the kernel level. And security, well, the Nostr daemon, is designed to isolate those private keys, using secure APIs like NIP46 so the keys aren't just floating around.
So the potential solutions are sort of baked into the architecture itself.
That's the idea. And what's really compelling here, I think, is that it's not just another app. It's aiming to be almost like a new kind of operating system for a decentralized world. A base layer for machine identity, value exchange, even consensus.
A foundational layer for machine economies. Okay. So wrapping up, what's the big takeaway for someone listening? What should they be thinking about?
I guess. Just consider the implications. A truly self-governing network of machines, organizing themselves, building value, maybe solving problems in ways we haven't even conceived of yet.
Hmm. What kinds of totally new problems could emerge and be solved by a network that's, in a sense, becoming sentient through its interactions? That's definitely something to chew on.